Lab number 3, where our objective is to find the mass of a black hole. We have data from a visible star moving around, and we have chosen as our origin the black hole. The mass of the star is a given value as delta T, which is a normal day in seconds, as we are using SI units. Now we have to see two velocities, the velocity in the x component and the velocity in the y component. We have also written our radius, and we have two momentums that we have to define. The initial momentum, which is the mass of the star, and the initial velocity, and the final momentum, which is the mass of the star and the final velocity. Now we have our dPdt, which is the elastic momentum divided by the elapsed time, and by Newton's second law, it is equal to our net force. We have the composite in a parallel force and a perpendicular force. The parallel is the derivative of the magnitude of the momentum divided by the dt times p hat, and our perpendicular is solved by f net. Now we have our gravitational law, that is g times the two masses divided by the r vector squared, and if we solve, we before can see our mass of black hole, how we solve it. Here we've got the analyzed motion and our three forces, perpendicular, parallel, and the net force. Now we can see what does it mean that the net force is equal to dPdt. That's because Newton's second law as the parallel force equal to dPdt parallel, and the perpendicular force equal to dP perpendicular. Now we've got to see what if question, and my answer is no, because the net force will likely be constant, and all the other things in the right hand side of the equation are constant except the black hole mass, which varies. And if we want to the force be constant, there is something more that may vary, that must vary for a constant force. And that's all. Lab number 3, black hole mass.